but others struggling a bit. So the ones that struggle a bit with maths will probably have to revisit some of the examples that I've done over a few times now. You won't be allowed to take that into the test. So in the past we've had online courses where you've been able to have that sitting beside you while you're doing the test, my examples. So this is more like an exam, I suppose. Now, also in the past it's been worth 20%, it's only worth 10% now. So the emphasis on the drawings as opposed to the tests. That's kind of a NZDE thing. They go through the different subjects and they tweak things as they go along. Sometimes they take bits out or add bits in, and with my one they've kind of mucked around with it for quite a bit over the last 10 years, and now they're sort of saying that you need a portfolio of drawings, but they do allow in there a kind of a portfolio test, kind of a test based on what you should know to do the drawings, but they said it shouldn't be much more than 20% of the course, so there'll be a 10% one for civil and a 10% one for structure. Now for some of you that's going to be, if you're repeating this year, you're all great, that's fantastic. I bummed the test last semester or the one before or something, so you know that'll work better for me. And for others where they got poor marks in the drawings, you know they're going to have to work harder on the drawings because you can't really make it up with a good test result. The other thing we're going to go over in the lab is how to get the volume out of the dam, the platform. So we'll go over that in the lab as well. So it's a bit of a heavy class this week, and a bit of a heavy lab, but there will also be a little bit of time at the end if you want to stay on. Remember the second part of the day, there's no one using that lab, so if you wanted to carry on and do homework or start on any other subject that's starting to get a bit behind, and you can stay in that lab and do it. Okay? I won't be there, but I'll be there till around about 3 o'clock. How are you enjoying Moodle at the moment? Good fun, eh? I had an online class at Otago on Tuesday, and it was like driving along the road and somebody putting the handbrake on and putting their foot on your brake as well. It was awful. Never mind. They weren't too bad, those students, and you know, considering how slow it was going. So there's probably coming up over the next year or two is going to be a bit of a choice of classes. I only know as much as the next person, but there's talk around about combining MIT and Unitec in engineering. What that means I'm not sure, but it could be that if you live in South Auckland you might have another option of going to MIT for one subject and coming to Unitec for another subject. Doesn't really help us Westies. I'm from New Zealand, so you know I wouldn't really want to do that, or I might have to go there to teach. So yeah, I know. Rather than, what's the saying, rather than bringing Muhammad to the mountain, I think they want the mountain to go to Muhammad. So the students, which I call the mountain, will probably stay in their select places, whether it's Unitec or there, and I'll be the one that has to travel. The other thing that's also happening is that as Polytechs are losing staff, and they might lose the person that teaches the subject, so they go, well, what are we going to do about it? Oh, well, you know, Roger at Unitec can run an online course, and if that happens, it's already happened with detailing modelling, our degree one, and so they offer the students a choice of either or. So you can do the one here face to face, or you can do the online one, which might suit if you've got family or classes or whatever. The online one's always after the 5 5 o'clock normally. Starts about 5 or 6 o'clock. So I'm not saying that these things will happen with your subjects. I'm just saying that that's the sort of thing that's happening in the country at the moment. Big decisions made above. Obviously they're saving money with online, but face to face is what Unitec is our speciality. You know, coming to class, having a coffee with your friends, you know, having to listen to me for a couple of hours. That's kind of our speciality. We've got all the labs and things here, so I don't think they'll be changing the labs around to, you know, surveying is another one. You'll have to do that, you know, face to face. Through COVID, those sort of subjects were pretty hard.
So Rhonda, is that for next semester? Is that being finalised for next semester?
Yeah. The other thing is, of course, if our good friends in the National Party get in and kick out our good friends in the Labour Party, then things will get turned around even more so. Labour, the current Te Pukenga, is aiming towards also a combo of online and industry teaching, as well as this face-to-face, giving students the three options, which in your first year, in my opinion, you should do face-to-face, come and make some contacts and friends and start, you know, getting used to the system. In the second and third years, depending on whether you're doing a degree or diploma, most of our students are capable of doing either all three ways of learning. We have to do classes as well as teachers. I call them, I won't say what I call them, but let's just say that we have to upskill. And we have the choice of online or turning up for a 2-hour thing. And I just can't be bothered going to the 2-hour thing. So I do the online, so I read the notes through and answer the questions. It's just a, you know, but it's about half of the teachers turn up, because if you turn up, they pretty much give you the answers, but you've got to sit through 2 hours of it. I don't know how you guys do it actually, to tell you the truth. So, yeah, just, I like to try and give students a wee bit of a heads up, so with those sort of things. We only know as much as our boss tells us, and our boss often tells us that he doesn't know anything either. But yeah, staff cuts are something that are inevitable. The more that they say there's going to be no staff cuts, the more you start thinking, oh yeah, right. So obviously if you combine two places, there's going to be a bit of a change in personnel. But they still need people to help industry teach, because you can't just pluck, industry can't just go, well, got all this work on, oh, John and Mary, you go and teach the students, you know, no training at all. So, you know, there's going to be a number of industries that go, yes, we don't mind training, but can you give us some of your teachers to help us out, you know? So there'll be a lot of that going on as well. Okay, so without further ado, we'll get into our notes, which should take us through to around about 10 o'clock. If Moodle goes quick enough, shouldn't matter too much, there's only the main block. I will be probably drawing a little bit on the board today. So you're welcome to take a shot of that when we finish. Oh, and yeah, so Labour wants the current system to continue on. National are talking about making 10 polytechs throughout New Zealand. And my best guess is that they would combine Unitec and MIT anyway, because there's 16 polytechs at the moment. you never know, they might combine us over in Southland and Canterbury and Nelson and, yeah.
So if you live out in South,
So-
then you have an option to,
to-
if national goes ahead.
If national, well, actually it's looking like, South, either or. I don't think, the national might keep Unitec and MIT separate, or they might combine the two, but they're talking about 16 projects down to 10. But no industry training and, no online, just back to the normal politics system. But, you know, that could be an election promise, and then, you know, like, yeah, just, and it depends who else gets in with them. I mean, if they're buddies with ACT and they're buddies with the Maori Party, you don't know what they're gonna be pulling on the strings for as well, you know, it's just the way things happen in New Zealand. They certainly won't be buddy with the Greens, but yeah, a bit of toing and froing going on. To me, they're both just as bad. Yeah. So there was also talk of having the civils here and the mechanicals at MIT. So, you know, so there was talk of having the civils all here and MIT having all the mechanics and all the electrical. So we've got an electrical here at Unity. So they're not that happy about that at all.
Yeah.
So, you know, they're bouncing around different ideas. Until things are settled, we won't know what's going on there. But don't be assured your qualifications will still continue. I did about half of mine by Open Poly, which in my time was absolutely no help. You got 12 little booklet things. You'd answer the questions at the end of them. The marks all ended up 20% of your mark, and then you had to submit external exam. And that was it. That was your training. So, because I worked on the Clyde Dam, which was in the middle of nowhere, so that was the only way you could study at the same time. And it was quite good in some ways, because there's a whole pile of us doing it up there, sort of bouncing off each other. And you sat with the high school kids in the exam, and so that was fun as well. Right, so we'll put this on. And I'll make, for those who've got their laptops with them, I'll make this available so you can see it a wee bit up close and personal. So, week 5, all right. So, last week we talked about cross sections, and this is probably quite a good diagram in terms of explaining a lot of things. The yellow bit is the platform, and the existing ground line kind of goes down sort of something like this. And these slices through our, that's the cut area, and this is the fill area. The slices represent a section line through at a chainage or a distance. Starting from here, 0.379, that's how many metres along the platform there is. Now, the way how you're going to do your volume for your assignment, and you'll notice there is a section there where you need to produce the volume, is you're going to draw, we already know how to draw a section line through our platform, because we've done one in each direction, or at least I showed you how to do one. So you should have maybe taken that a bit further this week. But of course the tricky bit's doing a section through the what I called the butterfly wing, or the fill or the cut. But that's not, I mean, we can't get a volume just off those sections. So basically what we're doing is we have a section here like this, and another section over here, and another section over here, and we have a distance to those sections. So in order to get the volume, we'll call that area 1, area 2, area 3. What it is area 1 plus area 2 divided by 2, plus area 2 plus area 3 divided by 2, but we also have to multiply it by this distance along here, and let's call that L1, let's call that L2, so that'll be L1 times that, plus L2 times that. So what you're doing is you're taking the average of these two areas and you're multiplying it by the length between them. So you would take whatever that area is, whatever that one is, whatever the length is, then the length times the average of those two areas will give you a volume. Now, for quite some time in engineering, that was all they did. So if you were an engineer on site and you had a pile of dirt that you had to get rid of, you would just use that very simple average end area method, right?
So those distances from contours?
No, they're not
Okay.
contours, they're just a made up distance depending, that would be up to you on the assignment, and it's normally up to you if you're on site. It may be that there might be a tree in the road there, so you decide to go 7 metres instead of 6 metres, or it might be that you just get nice and boring and do it every 2 metres. The trick is to recognise if there's a big change in the land. If the land goes down like that or up like that, there's going to be a change in the volume. So when you're doing your stepped off cross sections, always keep an eye on what the land's doing, and if there's something a bit different that could affect your volumes. The reason why volumes are so important is that if you have to take every truckload you take out of the ground has to go and get put somewhere. And in the summertime in Auckland, it's not too bad. Some of you may have noticed this morning our summer's starting to disappear. It's a little bit cold. Now I'm from Dunedin, so I've got to wear shorts, or my mates will ring me up and tell me that, they'll probably tell me to put a dress on or something like that. I'm not going to wear shorts. So I come from a very cold part of New Zealand where they wear shorts all year, right? But most people in Auckland would have rugged up today, put their jeans on, put their big coat on, going around crying because it's cold. And especially anyone coming from the islands, where it's about 50 degrees over there at the moment, 2 degrees here. But yeah, when winter comes along, what happens in Auckland, the farmers that normally would say, hey, you can put any spoil on my farm, I need that big hole over there filled up to make it nice and flat. They open up their gates and the truckies find out about it. For example, there's a farm on Mount Eden there, let's say that you're allowed to put some clean fill there, and the truckies found out about it for a job at Unitec, they'd be over there like a shot. Because the nearest one at the moment is South Auckland and way up Albany Way as well. And we know what the traffic's like. You take a dump over there at 3 o'clock, you aren't going to be back till 5, you know. And so that's a cost. Someone's got to wear that cost, and that's the cost of dumping anything from the site. So if the engineer gets the volumes wrong by too much, this is what happens, right? Then there's the other side of the coin, which is fill. Now, generally speaking, if you've got a lot of fill required, which our job does, it can't be just taken from a farm or from a house site around Auckland where they've cleared the house and there's some relatively clean fill. Because for a start, the water is sacred to the iwi, so they don't want anything flowing down into the water from goodness knows where. And secondly, you may have to compact it and get up to all sorts of engineering standards before you put your building on there. So the best way to get around that is to buy what they call clean fill from the quarries, which is basically gravel of different sizes. You do that in materials anyway, you know what I'm talking about. And then they compact it. Well, that's not cheap. That's even more expensive because you're buying it from a quarry, and the nearest one's quite a way away as well. So if as an engineer you get your volumes too much wrong, then you're costing your job a lot of money. So it's very important in the early stages to try and get that as close as possible. So what they found in the sort of 1930s up to the 1960s is that an engineer using that method was actually out by quite a few truckloads on a reasonable sized job, and they were wondering why that was happening. I mean, what's going on and why it wasn't proportionally, it might have been 5 or 10% out, but in terms of money, that's a lot. If the job's worth $1 million, you're out by 100,000, you know. So to cut that down, they brought in some mathematicians who originally came up with what they call Simpson's method. But the big breakthrough was in the prismoidal correction. And I'll just explain that just in a few words, because you don't really need to go into it in great detail. There's an example there at the bottom of those notes. But what they found was, it was all very well measuring the different volumes of each shape. But once the shapes became a wee bit different, we had a lot of different prisms starting to form. And then on a road network, of course, you've got to match into the current road. So you end up with this wedge-looking shape at the beginning and the end of a road situation. Now the road might only be, 100 metres or something like that, but you've still got extra material in there. If this gets wider at one part, then skinnier at another part, that you form what's called prisms on the side of the shape. So you end up kind of like a triangle prism shape. I don't know if you've all seen what a prism looks like in science. It's kind of looks a wee bit sort of like this. So you get these prisms forming all over the place that the engineer hasn't calculated with that method, the first method I came up with. So it fast became known as the prismoidal correction factor. You don't have to remember the formula. When you see the formula in the lab this afternoon, the first thing students do is go, whoa, do we have to remember that? And the answer is no, okay? It's embedded into most of the 3D modelling programs. So the cool thing is when you get into an office, you'll be given something like, say, Civil 3D, which is a bit like AutoCAD. and it'll be a 2D, it'll be a 3D model you'll be given, and you'll put a surface on top of a surface, and those programs using the Prismoidal calculation will work out the differences in the volume. But of course, you've got to get everything dead right. There's no use just going tap, 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 our computer says yes, sort of thing, I'll send that off to the client. You've got to be able to check these things, even in approximately. So you do need a way of doing that, and the quickest way is by doing a series, of sections with distances. When you've done that, you need to put it into a Prismoidal calculation sheet. Sounds pretty fancy, it's basically a spreadsheet. And I'll be giving you that in the lab, and what happens with that, it's pretty cool. You fill out the distance, you fill out the cross-sectional area, whether it's a cut or fill or both, and then you fill out the what the distance is between each chainage. So you've got a running distance, then the distance between each chainage, and it'll go down the bottom, and it'll just give you a number of too much cut or too much fill. All calculated out with the Prismoidal calculation factor, all done, right? And you can be pretty sure that if you put the right numbers in there, it's going to be pretty close. I can't say down to the last truck, but getting pretty close to that sort of level of accuracy. In this example here, using the N method, they got 9502.5 meters squared. When they put it in the Prismoidal method, they ended up with 9275 meters cubed, sorry, not squared, cubed. So you might not think that's a lot, but a normal truck is about 6 square meters. So every time you're out by 6 square meters, you've got another truck lining up on Carrington Road for your job, waiting to come or go. So if you put that into perspective, 275 divided by 6, whatever that comes to, it's around about 40 trucks. All right, and it's just by doing something using the end area method or taking advantage of the Prismoidal calculation sheet. So I give that to our students every year, and a lot of them will kind of just, I don't know, throw it out, delete it, whatever, when this course is finished. But some will take it through to their working life. And this is the sheet that the person, when they're doing the tunnel there, rang up and asked, he says, oh, I've lost it, can you send it to me quickly? I'm trying to work something out. It was at the end of the tunnel, and they were doing the ramps. A little bit hard to explain, the emergency ramps, not the actual motorway part itself. And they had a whole lot of what I call spoil or excess dirt there they wanted to get rid of. And they had to calculate how many trucks to order for the next day. And he had no fancy computers or anything on site, no 3D software to do it, yeah. And his boss had already been on the phone to me telling me, you're going to have to change your course, there's nothing. You need to change the course to make it more like what we do in the real world. Oh, is that right? Yeah. So, one of my important jobs when I was doing design was balancing the quantities. Now this can be a number of ways of doing it. You've got a platform. So, one of the ways on the platform would be to raise or lower the platform up or down, which will make more cut, more fill, less fill. So by doing that, you can change your overall balance of the quantities. In the perfect world, we would get a perfect balance of 0. Never actually happens exactly like that. And there's the next thing you have to take into consideration is something called the compaction factor. And the easiest way to explain that is little Johnny is a bit of a naughty boy. He's about 4.5 years old. So he hasn't quite gone to school yet. So he's at home all day with his mum, and he finds Dad's spade, and he digs a hole in the backyard, a bit like a dog. Dug this hole, big pile of dirt. Mum looks out the window. She's had enough of him for the day, so she says, "Right, you're in trouble. When Dad gets home, you're going to cop it." Now, my time that meant a smack on the bum, but these days you can't do that, so it's probably not allowed lollies for a week or something. Anyway, little Johnny says, "No, Mum, I'm a bit cleverer than you. I'll just put the dirt back in the hole and jump up and down on it. Dad will come home and never notice." So he puts all the dirt back in the hole, jumps up and down, stands there by the hole very proudly. Dad comes home and says, "Come over here, boy, you're in trouble." And he's like, "How did you know?" He says, "Turn behind you." He turns around and there's some dirt left over. Because the compaction factor of the dirt, even with his little body jumping up and down on it, wasn't enough. Alright, now we've all done that before. We've dug a hole and gone, "What the hell, there's dirt left over," right? So in Auckland, not the topsoil, but the next bit down, the clay, the Auckland clay, a typical compaction factor would be 25% versus a bulking, which means too much, of 30%, which would give an overall 5% left in the trench. Okay? Now, if you put that idea in your brain, that means that every time you have a truckload, in order to get the truckload amount that you want to fit into the hole, you'll need 5% less. Because when they think of ice cream being scooped out and put on the truck, right? And then, so you have to use those two calculations to calculate exactly what the bulking and compaction factor is all the way along the job. Now that is determined by a geotechnical engineer, not me. So once again, you've got to go to that very popular chap that's sitting at the back of the office. It is normally a male, normally looks a bit like me, normally old, and normally a bit of a pain, and they wait for the last minute to give you that compaction factor. So he'll give you two numbers, the compaction and the bulking, and we call that the compaction factor. And you have to apply that to your overall volumes.
Got a question?
Mm-hmm.
We got 25-30%, right? Okay, it's I think 25 we can use for the compaction. What about 30%? How are you gonna use? Like when we dig out, so then we build it back. You wanna be 30% over?
Yes. Yeah, so if it's a cut situation and you've dug it out of the ground, you're going to end up with 5% more than you calculate on that. Use if it's all that clay. If there's rock or gravel or topsoil, it'll be different, right?
Now it's only clay, right?
Yes. So in your case for the assignment, we're going to use those same numbers. You're going to have so much fill and so much cut, and you've got to think about what you add on or take off for the cut, and what you need delivered to site for the fill. So the tricky bit is, so basically when I'm marking this, I will mark your little cross sections you're going to draw through the site. There'll be probably, what did I say last week, somewhere between 8 and 10 of those. No trees, no path, no numbers down below, just a little cross section that looks sort of something like this with the platform. That's what one cross section would look like.
Okay.
Then the next one, 2, 3, you choose the distance, maybe 2 meters, it's quite a good one. And then the next one, and it might be a little bit different, it might be sort of a bit higher and it might be a bit less fill. And so I'll give you, for doing that, with a number beside each one, of these, this is area, so the area. I'll give you 1 mark for doing that, for doing between 8 and 10 of them. So that'll be worth 1 mark. Here's an easy half mark. You need to put those numbers into the Prismoidal calculation sheet, which means you need to turn up to my lab this afternoon to see how that goes. It is very simple. So that'll be the easiest half mark you'll ever get out of me. And then I always keep back a half a mark, there's always in my assignments, unfortunately, but it's the difference between my golden students and the rest of the class. I keep back a half a mark for working out, once you get the volume from the Prismoidal, for working out the compaction and bulking factor and what it's going to end up in. All right? And the best example is Little Johnny, I can tell you that.
Our cut section is small, right? The big section, we need to bring some stuff from outside.
Yeah.
So which means everything we bring, we're gonna reduce 5%, is that what you mean?
Everything that you bring from site, yes, you need to order 5% less. But remember, you can reuse some of the cut,
Yeah, we will use,
but that'll be 5%
yeah.
more. So there's a little bit of getting your head around that, and that's why I call it the golden mark for that, okay? So you'll find that in a lot of stuff that I do, you'll get a super easy, you'll get a reasonably middle to hard, and then a very hard last part. I do get a lot of complaints about that last little half mark. It's amazing how many students get pretty upset about that in the complaints section. Even though they end up with A's, they still have to have a little bit of a moan about it. So yeah, that's how that's going to work on your assignment, which is what most students want to know. But in terms of the test, I might say something like a compaction factor of 25, a bulking of 30 will give a compaction of 25, a bulking of 30 will give an overall compaction factor of 5% would be the answer, but it might be multi-choice. Alright? So, that's the difference between the test and this. But I mean, there's no harm in giving it a crack. The only thing that I ask is that last bit is summarised. Sorry, it's a wee bit hard for you to see that there, mate. This last little bit of whether it's what you do with your quantities is summarised on your notes on your proposed plan. These two bits can be in model space, miles away from you. I don't want to see a plan of those. Just want to see it in model space. That goes. Alright, and I want you to cut and paste your Prismoidal into model space as well. Once again, I can show you how to do that. There's a question on both the compaction factor and on ways to balance quantities in the test. So we talked about raising or lowering the platform. Another way of changing the volumes is to the sides of the platform, what we call the batter slopes, to make them steeper or to make them flatter. The only problem with that is we have to check with I keep pointing to the nobody sitting in the back corner there, the geotechnical engineer, to make sure that if we steepen it, that's okay. Because every clay, every soil, every gravel, every sand, whatever you've got on the land has a compaction, has a factor for the batter slope. and a geotechnical engineer will only let you go so far, and he'll say, no, that's too steep. Otherwise the land will do what it has been doing in cyclones, which is just fall away. Shouldn't laugh, but that's what can happen to a job. So they are options that the designer's got, but he or she has to check with the geotechnical engineer at the back of the room. We used to have one. We had one in the whole office, and I was always in and out of there trying to get an answer out of him before he went home. Otherwise, he could muck up your whole day's work. Mass curve diagrams. Mass curve diagrams are very interesting. So what happens mostly with the mass curve diagram is that we have a job, and it might be 500 metres of road, and about halfway along the road we start stacking up all the extra cut that we've got in a pile, and then it's flat again, and then we're stacking up some more cut, and then we need some fill in this hole, so the cut ends up being dumped into that hole, so it's nice and filled up, and then there might be another bit of fill that we need. They may have to bring that cut forward into here, and then we've got some more extra fill left on the job. So if you drive along any job when it's at the early stages, you're going to see big piles of excess clay or fill, but they may do the job in a series of stages, or they may do the job all the way from one end to the other end. Now, looking back at that plan that I first put up, which would be the logical way to do that platform? Where should you start digging? From the bottom, or from 0, or from 25? 25? Can you explain why?
There's less cut.
There's less cut, and what are you going to do with that cut? Fill the fill. Correct. So you're automatically thinking like a project manager, right? So I guess it's definitely worth half a mark. But you've got to email me before 12 o'clock tonight. He's dead right. You're starting from 25. As you're cutting it, you're moving it forward into this fill area in here. So it's good project management, because it's not till you get to around about 7 that you're going to have to start getting some more fill from off the site. But if you start from this end, you're getting fill from off the side, 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 all the way to here. And now you've got cut, which you've got nothing, you can't get rid of, so that's got to go off the side as well. You've got to get rid of that and dump it. So bad management would be starting from 0. Now, that's a fairly simple one, okay? No disrespect, but that was a pretty simple one to get, a pretty simple answer. But sometimes it gets complicated when you're going along the road and you've got different bits of cut and fill. So you will see them on motorways do that bit. And then you're seeing a big pile of there going, well, they haven't touched that for weeks. What the hell are they doing? You know, they said they'll be opening up the motorway in July, and they've just still got this big pile sitting here, because they may be combining that with something else, or they may think that that's just a bit too far to drive to get rid of it, and they can get rid of it another way. Or they might be waiting on the final design, which means they might be able to use this to spread it across. There's all different reasons for it. So you can see that the two areas are kind of meeting. You've got me as a designer in the office trying to balance my quantities and as best I can, and then you've got the project manager around the corner there, who's trying to figure out what parts of the job to do first, so that he minimises the cost. And to do that, they do have some pretty good spreadsheets and programs these days that are kind of like bar charts. This job can't start till that job starts, till that job starts. And, you know, every day they play with those and see where the job's going to end and who's needed on site and who's not needed on site. But that's not my job, that's the project manager's job. But if I stuff up my volumes and my areas and all the rest, it becomes my problem, because the project manager's going to come back to the office and say, you're out with your volumes by X amount, and it's stuffed my job up completely, because I need these guys on site, these guys, etc., so it compounds their job. You can't be, civil engineering's not an exact science. It's not like structural engineering where, you know, you need 5 bolts and they're 5mm diameter and they have to be exactly there, or else one bolt won't fit through another bolt. You know, it's not like that down to millimetres. So don't get too upset if your calculations are different than yours or yours or yours. It's already you're all going to be different with your contours, and so therefore the volumes are going to start coming out slightly differently as well.
Yeah, one more question. So I can see the what's it called? The platform on this side, the down. So this, what you draw in the whiteboard is like sideways, right? For this one.
It's the view going that way.
The sideways.
Yeah. Yeah.
So we need to draw this one exactly like that, or just we need to put the number is important? Because
This area here is the important bit. So you draw around that area with a P line and list it, and it'll give you the area.
Okay, so
Yes, you do need to get the ground line right, so you probably have to draw the ground line with 3 or 4 things going up, lines going up, and you get the ground line, and then you take a line up for the platform, whatever level it is, and you've got your
which means the big to small piece, right? The drawing. Because when I see this one, like 25 0 we go on one row, and 23 3 is on one row, something like that. How it goes?
you need the distance between the two as well,
Yeah.
which you put into the spreadsheet, and then the spreadsheet will tell you the volume. It's as simple as that. It's not hard, but because I'm showing you the Brismortal calculation sheet, there's also some questions on that in the test. Okay, so you need a little bit of an understanding of that as well. The next thing that you need to know is the mass curve diagram, and I'm not sure whether it's at the end of this or not. No, it's not. I do have on Moodle, I'll just go back, hopefully it'll catch up with us. I do have on Moodle a mass curve diagram exercise. And I'll show you how a mass curve diagram works, maybe, if it lets me. One, two, three, 4, 5. prismoidal lab test. Okay, so we're using the same example, and basically the mass curve diagram pretty much explains what you came up with why you should come from one end and not the other end. So I've got some cubic meters going on here. They're actually square meters for the sorry, I've got some square meters from the cross sections, and this is what the answer to it is. So with a mass curve diagram, you can see back up here, if we started from 0, we would end up accumulating fill. So anything below the line is a cumulative fill. So we got lots of fill, lots of fill, lots of fill, and it doesn't turn around until chainage 14, which is about here. And then we start getting some cut, so the balance comes up, but not very much. It comes up to about here. So we end up with, in terms of mass curves, way too much fill. Whereas this way, starting from 25, so that's 25 going backwards, we are accumulating cut, which goes above the line. Okay, and then about here at 18, 14, which is about here, we start accumulating fill. But it's not until we get to between 9 and 11, so if we go up here between 9 and 11, that we actually start getting a balance. So the job here, all this part here, the first part of the job, will balance out, and from about 10 onwards, we've got to get rid of, we need some extra fill. So when you get a curve like that that goes past that point where there's an equilibrium and back down, it's the perfect curve for doing the job. Whereas this top curve is, all you're doing is most of the time accumulating fill. So that's why we use a mass curve along a job, and you'll see when you go all the way along a job, the curve will be doing this, right? And that'll be where the good project manager will point out the bits of the job that they should be doing or grabbing extra bits of cut or fill from. Not normally a designer's job, but they need to have a wee bit of an idea of the mass curve diagram. You're probably going to start using something like that in project management, as one of the subjects on the diploma, plus another project management program, which I won't get into. So going back to my notes, There are some properties of the max curve diagram which is also in the test. So when the curve's going upwards, it means the quantity of cut is increasing. When it's going downwards or descending, it means the quantity of fill is increasing. When it crosses the horizontal line, what does it say, that max curve datum line, when it crosses the curve datum line, the quantities balance. We saw that on those diagrams that I pulled up for you. Now on a fairly large job like we're doing here, there's an order of drawings, and I want you to take note on your tabs, the order. We don't have a cover sheet, but existing site plan should be your first one. Not the long section next, it should be your proposed site plan. Then your long section, then your cross sections, and then any details or boreholes or drain plans which you don't have, or general details. So that's your order of drawings, so make sure your tabs are in the order, okay? So there it are, that's pretty much spelled out for you. Existing site plan, proposed site plan, long section, cross sections and cross sections. Now you can pick them up in AutoCAD and just move them around on the tabs. Just pick a tab up, slide it along. Checklist for your proposed plan. Okay, I think what I'll do is I'll show you a proposed plan, which was a C student's work, and I'll point out the good, the bad and the ugly. It's a good time for you to take some notes on how you can get your one looking like the good, not the bad and not the ugly, alright? So, there'll be similarities, put it that way. Sorry, noodle was taking a wee while. So you're all still aware that Wednesday lab is happening. You're welcome to turn up to that and ask is it a lady, is it Carla, is that her name? I haven't. If she doesn't know anything, just tell her to email me and ask, that's probably worded that wrong, if she doesn't know anything. If there's something she's stuck on and doesn't quite have an answer, rather than guess and say this, then she should just email me and get the correct answer, so that she doesn't tell you one thing and then in the assignment I mark you, separately, because I can't take, Carla said this as an excuse for giving you more marks, right? So if she hears it, just tell her that if there's something she's not sure about, email me and we'll get the correct answer out to the students, all right? So we'll be doing a lab exercise in class in week 5. I'll keep that up my sleeve at the moment. But what I did do is under the assessments, which is up here, under just under assessment 2, I've put an example of a proposed plan. Now, the important thing about the proposed plan is it is very different than the existing site plan. So the existing site plan has got the pegs on it, and it's got the peg line between the pegs, right? And it's got the bearings and distances on that peg line, which was one of my golden marks. Because last semester in technical literacy, you put bearings and distances between the pegs, right? So that was your little golden mark there. Some students may have talked to others from the past. Yeah. The peg size was approximately the size of your text, 0.35. And that sort of was all you put there. Maybe you might have put proposed platform in the middle, a rough square meterage or the distance or something like that. No flags, no butterfly wings, and a few notes about the trees and bits and pieces, right? Well, that changes now. The platform on the proposed will be a solid line.
When we can get our feedback about assignment 1 so we can continue assignment 2?
3 weeks is your normal time for feedback. I think the hand-in's 3 weeks, isn't it? No? Is the difference between assignment 1 hand-in and assignment 2 hand-in is 3 weeks?
No, I mean when we get our feedback, the results.
Yeah. Well, feedback is normally, well, you actually just got some feedback just then. You got to also remember there are students that will be trying to hand in late. If I say too much, just giving them more marks, aren't I? I'm rewarding bad behaviour. There's two types of late students. The ones that either legitimately or illegitimately making up excuses, and there's also the ones that are happy to take a hit of 20% off because they're listening in the classes and picking up some extra things. So for example, I said the PET line between the 2 points, which most of you would have done because you've been in all my classes. And I said that the circle should have been, the peg should have been the same size as those 0.35, the survey peg. And I also said the golden mark was to put on distances and the bearings on those lines because they're survey lines. When you come to the proposed plan, the distance and the bearing, gone. Circles, gone. Pegs, gone. It's a solid square line. But what will be added will be your butterfly wings, your design contours, a bit like this one. You see the design contours for the fill and the design contours for the cup. And you'll notice that there's also the big line, little line, big line, little line. That's your indication of the batter slope. But over here, they've had to go pretty sort of careful of, they've done a slightly smaller one to fit it in. Absolutely nothing wrong with any of that. But then we get to the platform, we get to the flags. Yes, you do need the flags on here because you have to indicate your cross sections as per technical literacy. problem I've got is that that flag should have been extended out to over here, well away from your design contours, and well away so that the B can be read properly without lines in it. Same with that one. Same with that one. Now, if there are contours in the road, break them away from them. This one's the worst one. He's hiding behind a tree. Yeah, so you may have to kind of delete the tree behind it, or
Oh, top one.
yeah.
Put the tree.
The pipe doesn't change much. It's still there, because it's in the ground, it's going to be dashed. And you always have to provide a centre line because it's curved. Otherwise, if it was a rectangular pipe, you wouldn't have a centre line on it. This student did a bad mistake. That pipe was supposed to go from there to there. For some reason, they did a diversion on it. Some excuse about, oh, it would have been a better route to take. Yeah,
You said pipe would be the hidden line, right?
dash because it is in the ground.
Okay, so what about it's under the platform, what we should we do? We're gonna dash through the
Dash, yeah.
dash through the platform?
Yeah.
Okay.
Now you will notice another thing the students done. They've taken out the existing ground lines under the platform and under the butterfly wing. That is 100% correct. And look at how nicely these contours come in and meet the one, go around and come out the other side perfectly. So it's done a very good job of that, and that's why this was a pass mark. The arrows are a little bit over the top on how many there are, but for all drawings that go to council, they want to see what's called flow arrows. And I like the fact that they've done the arrows different than a normal leader. And hopefully it's on their key as well, is it? Yeah, overland drainage. The reason for overland drainage arrows is that you can very quickly see where the water's going to go to. And councils particularly want to know whose place it's going to be going to and where the possible flooding might be. And we've talked about that so much over the last 2 or 3 months. I wish they did that at Mount Smart Stadium and they had the water flowing away from where you bought your food and your beer. But never mind. I have my family and friends were very, they laughed their heads off when they saw me. I had a plastic coat on and I was up to my knees in water buying beers and food before the Elton John concert. And there was a couple of Asian guys were selling coffee in a caravan, and the water came up and the caravan was floating away with the minute, and they were saying no coffee, no coffee. Yeah, it was pretty bad. Never mind. You get someone like me that doesn't go to all these events that are on. I don't go to Ed Sheeran and all those other ones. I turned up to the one that I wanted to see and ended up getting soaked. Never mind. It was an interesting night. I took 2.5 hours to get home. So yeah, these flow arrows are important on all construction sites because they need to know in a 100-year event or an Elton John event where all the water's going to go from the platform that you've put in there. So put that on your proposed drawing. I don't like the fact that they've done all this stuff up here. It should be down the side. And guess what? You'll get marks off if you put a locality plan there. Locality plan is for the existing site plan so that the truck drivers, the project manager, the guy that puts the cones out, the labourer that turns up the site the first day, they all know where to go. After that, the proposed plans are not used for that side of things. Also, sometimes not everyone gets a copy of the proposed plan. They tend to not dish them out as much, only to the contractors that are doing the work. So we don't need that. We don't need the survey coordinates either, because the pegs are gone at this stage. So just notes and anything, and your legend, please.
Where shall you put those?
They're on the existing site plan. You don't just keep putting them on everything.
Oh, okay, so we don't have to.
No, you can go save as.
Yes.
You can copy it to the side. Now, in the real world, we wouldn't do that. In the real world, we would actually draw on top of our existing site plan the proposed plan, put things on different layers, and in each viewport, we would go inside it and freeze the layers we want on and off. Doesn't affect model space, just affects each viewport, because we like to keep the coordinates in their same coordinate base. So if you click on any point, you get a coordinate at any stage. That's in the real world. In Roger's world, you don't have to do that. I made it easy for you. Just copy your plan to the side and start doing your proposed plan, all right? And just on your viewport, pan along, hand to Maradona, don't use the other one, so that you keep the same scale, and on top of your proposed plan, start drawing, on top of your existing plan, start drawing the proposed plan, all right? I hope you all got my email about that point that was wrong on the file, and I hope you all understood that you weren't supposed to take any triangles through the contours that were given, because otherwise the volumes would be a wee bit odd.
So how about the notes? Where shall we put the notes?
Down the side like you did last time,
Sorry?
down the side of the,
Outside.
yeah, in fact,
You mean the like existing plan?
yes,
You wanna open the another?
yeah, if you right click and go move or copy and go copy, you can copy existing site plan and everything will be there, all set up for you, but you'll have to pan along for a new set of notes, which will be similar. And this is the bit that I'm looking at. I look at your proposed plan notes and I look at your existing site plan notes. And some things now should have changed. Because not only have you done sections, but you've done a long section, and you're now beginning to know things that you didn't know when the job first started. So there will be some change on the notes, and I'm looking for that. I just don't want just a straight copy, so I'm looking for some changes in your notes. So just be aware of that. Also, another thing wrong with this drawing here is they've done a centre line through the sections. Now, if you remember back to that little sketch you had to do for Ingrid, no centre lines through. Now, some of you would have done that on that sketch and got a bit cross through it. Okay, so you just do the section flags. They can be solid if you want them to be. And those ones there are not a bad shape either, they're not a bad size. That North Point's way too big. I think they copied my North Point. So if the student that was asking for feedback, I do try my best to give you some feedback before assignment 2. So if you've done a great big North Point like that, that'll probably be on your feedback. The thing that disappoints me the most is that I do try to do that 2 or 3 days before hand-in, and the amount of students that don't read that. And what I tend to do with assignment 2 is go, instead of saying you've done it again, I'll just have a look at your comments on assignment 1. That's your feedback for assignment 2. Okay. I don't like seeing things, when I tell you something, in the feedback, and then you go and just repeat it again in assignment 2, then it sort of makes, I've got a lot of other things I could be getting on with, you know, like sleeping or patting the dog or something. I don't have a dog actually. So yeah, read it and see if you can improve on it. I'll tell you something for nothing, and I've just had a quick look through some of the drawings. Here's another bit of feedback for you. The title block should have been on a layer called title block. The viewport should have been on a layer called viewport. And the logo should have been on a layer called logo. If you want your full title block marks. So now might be the time to start changing that for assignment 2. And for those that haven't handed in, there we are, you've just gained a little bit more marks from your late hand-in. By the way, late hand-in is 20% off. So they're starting behind. There's a couple of students here that answered questions. There is a column that'll have the bonus side of it on there. Anyone that has put the bearings on the pegs between the two will get a bonus half mark as well. So there'll be a bonus half mark for that, but you answer the question. If you've done both, you still only get half a mark. Yeah. Last semester, I gave a half a mark for those with more than 15 or more notes. So change it around a bit. If you're here next semester, try for the 15 or more notes, eh?
Too much, it can't fill. That's too much words. You can't put it in that box.
Yes, I know, but there's ways of shortening it, I guess, or you can make your locality plan smaller. Everybody likes Roger until they get their first assignment mark back. Look, I come from a background, and I left consultancies in 2012. I've been here since 2003. But one of my main jobs was a red pen and checking the drawings, A1 sheet drawings. And I had to pick everything up because that was what we did. You know, if you didn't line your text up, you didn't put a leader in the right place, you got a circle around it. And you know, I had a team of females and males working for me, and they soon got used to it. You know, yeah, it doesn't take long, a couple of circles on the drawing every time. You know, you go, when you're doing your leader, you go, well, hold on a minute, yes, that's right. You just take a couple of seconds to get it right the second time around. Yeah, I did have a couple that I employed that decided they wanted to do things every time their way, and they don't last too long in the office. So yeah, that I used to call it putting blood on the drawing, but I also had a boss who was very fussy about that. He was an engineer, but he thought he was the best draftsman in the world, so he would also put circles all over the place. So on a Friday, my guys would arrive and girls would arrive in the office. I used to let them arrive late on a Friday, maybe 9 o'clock, 10 o'clock, and on their desk would be drawings full of blood, and they had a 5 o'clock deadline to get them out. So that was the pressure of drawing in a drawing office. But you see, to me, that's not a big pressure. You can hit that deadline by going as fast or slow as you want. On site is a lot more pressure. You know, you've got a guy on the digger, and he's saying, I've got to be back at the office by 4 o'clock. Sorry, mate. You know, you've got another guy in the truck saying the same thing. You've got often you'll have a site supervisor who's running around making fun of you. You don't know anything. I'm the boss. Suddenly something goes wrong on site. It's the engineer's fault, not mine. Yeah, I'm just the worker, you know. But all week he's been saying he's the boss. Yeah, so there's a lot of pressures on site that, I mean, traffic management turn up. That's the worst one. And, you know, they'll walk around like the police and go, "There's a cone fallen over. Did you realise that?" No. Oh, if you don't pick it up now, I'm closing the whole site down. You know. So, yeah, there's different pressures on different jobs. My guys used to work very late on a Thursday night. That's why I let them come in late on a Friday, because they knew that they didn't want to be pushed for time on the deadline. Yeah, so usually site work's a lot better paid, by the way. You'll learn a lot and you'll be a lot more valuable both overseas and in future jobs. Whereas in the office, it's not paid as much, but it's nice and comfortable. You don't get dirty. You get nice soft hands. The worst story you can tell any of your friends is you might got a paper cut or something like that. But it's a good steady job and you always get the weekends off. Whereas on site they're often working Saturdays and long hours as well. In summertime they work sort of 6:30, 7 o'clock through till 6. Yeah. So horses for courses. So with this volume side of things, I'm going to show you this afternoon what I want in terms of model space. If it was this drawing here that we were doing, I would require you to do about between 5 and 6 cross sections from there to there. But I would also expect at least one in the fill area. The easiest way to do that is to follow one of these contour lines with your cross section, because we know the height of those, so we can draw that little piece on there. So what it looks like out of there, if I can draw it, it'll be, instead of, this is what we normally see, right? That's your normal platform there like that. But when you come out of the platform, what you'll see is a little piece like that and a little piece up here like that. And those points there and there, if you go along a contour line, they automatically become those 2 points there and there. If it's along here, it'll be a longer one. All right, and that's how you manage to get a cross section through the fill area or the cut area. So I need to see between, say, whatever I said before, 5 or 6 or 7 from here to here, and at least one in each side of here. And of course, the last one will be 0, but you do need to take that distance because it goes from 0 to a number. That's important for the Prismortal calculation sheet.
Second from the left, we don't need to draw, we only draw only the feed section, right? Well, you're drawing always the feed and cut section, okay, right?
Those little sections here are in model space only. Don't want to see a plan of that. You don't have to put the sections on here. All right? They're just to work out the volume. And I will check at least one of these that you've done it right. And I will check that those numbers have gone into this Prismortal calculation sheet. because you'll be pasting the answer back onto the model space. Yeah. But in the notes section on this proposed plan, you need to summarise that last bit, which is little Johnny and his hull and the 5% compaction factor, and yeah. The cross sections need similar detail to the long section. So need a tree, they'll need a path if it crosses a path, and anything in the background. Now someone asked me online which way you're looking on the cross section. We're looking back up the hill at the manhole.
You mentioned before, we don't need to draw anything on the first part. But what do you say about it? You say, you mentioned it before, earlier,
Yeah.
but we don't need to draw anything like on the one of the crosses. You say that?
You need to do 2 cross sections,
Two cross sections.
A and B,
Okay.
and on those ones you detail them. So you need the numbers down below for any of the cut and the fill, the proposed, the pipe grade, etc. But on these ones, no.
Yeah, we do it without.
So you've already got that one.
Yeah.
So if I said you had to do 6, you could do 1, 2, 3, or 1, 2, 3, 4, 5, 6.
Yeah.
But that one there you've already done it in a big detail, so you already know the area for that one. All right? We're not going to do it in that direction. The reason is the contour line is similar to that, and we're not going to get a very accurate representation, because you're going to end up with just kind of fill. Well, everyone, is there any other questions? I've got to get back to my office to get my AutoCAD upgraded. No more questions?